Okay, so we're going to have a look at this question 5. It's a question that gets trickier as it goes on. There's lots of notation and combinations of symbols. Hopefully, when people see the color in the Venn diagram of the various sectors, they can associate that with the symbols being used in each particular question. And we do need to talk about this word associative as we go on, and we'll just visit it quickly here at the start before we see it. We'll need it for parts H, I, and J. So, what does associative mean? Well, it just means is the order important or not? If it's associative, the order you do operations isn't important. So for example, addition and multiplication are both associative. So let's see why with an example before we explore this sets question. So if I said to you 2 plus 4, and I added them in a bracket, say, and then I added 3 to that, 2 and 4 is 6 plus 3, well, that's 9. What if I had changed the order and decided to add the 4 and 3 first by putting that in a bracket and then adding the 2? Well, 4 and 3 is 7, plus 2 is 9. So we can see that the order there doesn't really matter, and that's just called associative. If we have a look at multiplication, it also is associative. If I have 4 times 2, let's say, in a bracket, and then I multiply it by 3, well, 2 by 4 is 8, times 3 is 24. What if I had decided to multiply the 4 by 3 first, and then multiply it by the 2? Well, 4 by 3 is 12 times 2. That's going to be 24 also. So you can see that with addition and multiplication, the order you do something isn't particularly important. And later on, we're going to see, well, is A without B and then without C, is that the same as A without B without C? And so if it is, well, then it's associative. And if it's not the same, well, then it's not associative. Let me give you an example of something that's not associative. Subtraction and division are not associative. So subtraction and division. Let's see why. So if I said to you that we were going to do 4 minus 2 minus 7, let's see if I put the brackets around the first two, whether it's important or not. So 4 minus 2 is 2, 2 minus 7 is minus 5. Well, what if I had decided to say 4 minus and then 2 minus 7, put the 2 minus 7 in the brackets? Well, 2 minus 7 is minus 5, and 4 minus minus 5 is 4 plus 5, which is 9. And we can see we don't get the same answer if we change where the brackets are and if we change the order we do a sum. So a division example, if I had 24 divided by 6 divided by 2, well, if I did 24 divided by 6 first, that's 4, and 4 divided by 2 is 2. Well, what if I had changed the order and done 24 divided by 6 divided by 2? Well, I'd have to do 6 divided by 2 first, which is 3, and 24 divided by 3 is 8. So hopefully that's an example of why addition and multiplication are associative and subtraction and division are not associative. We're going to investigate if set difference, the backslash, is associative, and then later on whether union and intersection, whether that's associative. And that's the big, I suppose, issue with this question. The early questions are actually quite easy. So let's delete that and move through the question. So the first thing is, write down all the numbers between and including 3 and 6. So A is equal to the set 3, 4, 5, and 6. B is the first 5 prime numbers. So prime numbers are numbers where the factors are only 1 and the number itself. So we have 2, 3, 5, 7, 11. We don't include 9 because obviously 3 times 3 is 9, so it's not a prime number. C is the set of factors of 6. So the factors of 6 are 1, 2, 3, and 6. Don't forget to include 1, and don't forget to include the number itself, which is 6. So the D part then and on through to the H part ask us to actually do some operations on this. So the best thing you can do, even if you're not asked to do it in the question, is to draw a Venn diagram. So I've drawn a Venn diagram and I've placed all of the information in the Venn diagram. To fill out this Venn diagram, I first filled in what was in the middle, which was 3. 3 is in all 3 sets. In A and B we had 5. In A and C we had 6. In B and C 2 was common. And then we had 4 left in A, we had 7 and 11 left in B, and we had 1 left in C. And there was no universe in this question. You've probably done some questions where there's been a universe, and if there was numbers left over in our universe, obviously we'd put them on the outside of the circles. So the question asks us to find A union B. So I'm just going to colour that pink, and we can see that A union B is all the things in A together with all the things in B. So we have 2, 3, 4, 5, 6, 7, and 11. And we're just going to write those down. Then it says hence, and when it says hence in a question, that means use the information from the previous part to get the next part. So we know that A union B is these two pink circles, and then intersection C, where does that intersect circle C? So what in the pink circles, okay, what bit that's coloured pink is also in C? Well, we'd be left with 2, 3, and 6. And so that's A union B intersection C. Okay, the next part, part E, a similar type of question. It asks us for B intersection C. So B intersection C is what's common to B and C, so 2 and 3. And then it says hence, so again we're going to use that information that B and C, B intersection C is 2 and 3, to answer the next bit. What's A union B intersection C? So what they're asking is, what's in A together with anything in the middle of B and C? So I'm going to colour in all of A, and then obviously together with the bit we had already coloured, which was B and C. So we have 2, 3, 4, 5, and 6. Part F asks us to list the elements of A without B. So this symbol here, we say without, but its symbol is set difference. So what's the difference between A and B? So what's in A without any of B? Again, I'm going to colour in the part of A that isn't in B. So 4 and 6. And again, hence, so using this information that A without B is 4 and 6, they're now adding in, well, what would that be without C? So look at the blue bit, which is A without B. And then what would that be without C? Well, we'd be left with just 4. So A without B, without C is 4. And keep this answer in mind when we go to do part H in a minute, which is about the associative rule we mentioned earlier. The G part of the question then says, well, what's, first of all, B without C? So what's in the circle B if we don't count any of the things in C? Well, it's 5, 7, and 11. Then the subsequent part says, hence list the elements of A without B without C. So B without C we've mentioned is 5, 7, and 11. So I'm just going to take note of that purple piece. What would be in circle A if I wasn't allowed to include anything in B without C? Now B without C is the purple piece. So what's in circle A without the purple piece? Well, it's going to be 3, 4, and 6. And again, keep that in mind when we go to do part H, which is the next part. Okay, so in part H then they ask us, is set difference associative? Is it the same to say A without B and then without C as to start with A and then say without B without C? Well, I've drawn them up here. Remember that the answer to the first part, A without B without C, is 4. That's that blue piece. And then if you change the order of the brackets and you decide that it's going to be A and then without B without C, remember that that is the grey part here. And so, is the blue part the same as the grey part? No. And so A without B without C is not the same as saying A without B without C. And so, set difference is not associative. Remember, it is associative if the brackets don't make a difference to the answer in the question. In this case, they do make a difference. The order you do things makes a big difference to the answer in this question. Okay, what about parts I and J? Well, they're going to ask us, are intersection and union, are they associative? And the best thing we can do is just to do them piece by piece. So if we go to I want to find A intersection B intersection C. Well, first of all, A intersection B is that pink piece there, the bit that's common to both A and B. And then C is obviously all of circle C. So what I'm asking is, what's common to both these diagrams? I've coloured in A intersection B on the left and all of C on the right. And if we were to say A intersection B intersection C, well, we're only talking about the number 3. That's the only pink piece that's common to both diagrams. So A intersection B intersection C is the number 3. Well, what if we change the order? Let's say we had done A first. Well, that would be colouring in circle A. And then we had done B intersection C. And B intersection C would be the parts of the circles that are common to both B and C. Now, what's common to the diagram on the left and the right? Like what part has been shaded in both diagrams? Well, again, it's the number 3. So A intersection B intersection C is also 3. And so what we can say is that intersection is associative. Both of these answers are the same. The answer is 3. And so the order you put the brackets wasn't important in this question. We ended up with the same answer. Okay, let's see if union is associative. So I'm going to find A union B, and then together with whatever's in C, union C. So A union B, first of all, is all of circle A and all of circle B. And then C, obviously, is just circle C. And if I was to colour in all of circle A and circle B, together with anything in circle C, so union C means together with or as well as, I'd basically be colouring in everything. And my answer would be 1, 2, 3, 4, 5, 6, 7, 11. So you'd be colouring in everything in both circles. What if we had changed the order and first coloured in circle A, counted all those elements, and then we had done B union C, we would get all of B and all of C. Now again, union, if we put down a union symbol, that means the left-hand diagram coloured in, together with all that's coloured in on the right-hand diagram, well, everything in both diagrams would be coloured in. All of the elements in the three sets will be included. And so your answer again would be 1, 2, 3, 4, 5, 6, 7, 11. So the answers to both of these are 1, 2, 3, 4, 5, 6, 7, and 11. And that's also the answer to the top one here. 1, 2, 3, 4, 5, 6, 7, 11. And so what we can say about union, as we did about intersection, is union is associative. It doesn't matter what order you put the brackets, you'll end up with the same answer. Yeah, definitely tricky stuff if you're trying to go just on the basis of the symbols and you don't have any diagram to work off.